Hello, my name is Abbie Martinez, and this is my lab report on line charges. Introduction. The purpose of this lab was to design an experiment using household objects to become familiar with the idea of a charge, to examine the charge interactions between objects, and to create a computational model for two charge states that exert an electrical force on each other. Fundamental physics principles. The first physics principle was the gravitational force, also known as mass times g gravitational constant, where g is 9.8 meters per second squared. This lab also used charge dense calculations where the electric charge E is equal to 1.6 times 10 to the negative 19 coulombs. The electric force is boxed in orange, where the force on A is equal to the charge of A times the electric field of some B acting on A. The electric force law is boxed in blue and states that the force of Q is equal to the K constant times the product of the charges, all divided by the magnitude of the position vector squared. This image actually has a typo and should not include the magnitude bars. Brief preview of main results. These are the assumptions that this lab utilized. Importantly, that the tape is a line charge and not a point charge. F net was equal to 0. The magnitude of charge on one piece of tape acting on a line charge was approximately 1.9 times 10 to the negative 9 coulombs. Models with descriptions. In part 1, we examined the U-tape and found that the U-tape was attracted to both neutral objects and a negatively charged pen. The tape repelled the other positive tape, indicating that the U-tape was positively charged. In part 2, we observed the separation distance and found that the resulting separation was 1.5 centimeters. Here we have the measurements and assumptions used when making calculations later in our conclusion. Importantly, F elect is equal and opposite in magnitude of F grav, and F net equals 0. The tape is a point charge, and charge is evenly distributed across the tape. Lab 2 assumed F net equals 0, so the magnitude of the force of gravity is equal to the magnitude of the electric force. The value for Q on line 16 was estimated using guess and check method until F elect and F grav magnitudes were approximately the same value. The set of code is a function that creates a line of uniform point charges, also known as a line charge. Lines 57 and 58 create variables that will store values for both the top and bottom tapes. The for loop iterates through each point charge and each line charge for both the top and bottom tapes and calculates the dE and resulting electric field for both the top and bottom charges separately. The top tape is red and the bottom tape is blue. Discussion and results. Here we calculated the magnitude of F grav and equated it to F elect. We used the fact that F net equals 0 and solved for the charge of the tape Q, which resultingly equaled 7 times 10 to the negative 9 coulombs. This was all part of the observational or the observed experiment from lab 1. The yellow force was equal to the force of gravity. The orange arrow was the electric force. F elect is the sum of all the individual electric charges on the surface of the tape. This distributed electric field for every point charge is represented by the purple arrows as seen in the image to the left. The blue line is the bottom tape, and the red line seen at the very edge of the purple arrows is the top tape. Possible sources of error. Excess handling of the tape in the observational model may have led to a lower calculated charge than actual. This is because when you touch the tape, some of the electrons are transferred from the tape to the hand. The value of Q for the glow script model was estimated using guess and check method, so this may not have been totally accurate to what was real. Conclusion. What if you had modeled each of the tapes as a single point charge like in the previous lab? For lab 1, we calculated the value of the point charge as 7 times 10 to the negative 9 coulombs, and for lab 2, where we considered the tapes as a line charge, we calculated this value to be 1.9 times 10 to the negative 8, which is a much higher value than the value for lab 1. Why do these estimates differ? Lab's 2 value is more likely to be closer to the real value since lab 2 calculated F elect for each point charge and summed them together individually. This is more representative of real life than assuming all point charges had the same magnitude of electric force and were all existing in one point.